We all know that the shortest distance between 2 points is a straight line. But what if you want to trace the shortest path between 2 points along a curving surface? Any path that follows along the surface will have no choice but to be curved. So how can we know which path is shortest between 2 points on a sphere? As a way to describe our sphere, let's consider the Earth. We can pick 2 cities, New York and Istanbul. These cities lie at the same latitude, so they share the same north-south location and are only offset east-west. Perhaps the shortest path from New York to Istanbul would be to trace a line due east. Moving only east and not veering north or south seems like the most direct route. If we were to continue the path on past Istanbul, we'd see that it would continue on around the globe and create a complete circle. The east-west path is just a section of that circle. However, if we take this path, keep the ends locked down, and try to shrink it, we'd see that we can pull it shorter. But this new path seems to strangely arch upwards through the North Atlantic. So why is this path shorter than the one running directly east? If we extend this shorter path on around, we'll see that it too will loop around the Earth and close to make a circle. And this circle is larger than the one we drew before. If we think of our paths as sections of circles, we can see how tightly they curve. Smaller circles wrap their curvature more tightly into a smaller loop. A larger circle will spread that curvature out over a broader loop. The shortest path will have the least amount of curvature, and needs to be part of the largest possible circle that can be drawn on that sphere. The equator is an example of such a circle, wrapping around the full width of the globe. This circle can rotate and maintain its size, as long as it keeps its center at the center of the Earth. And this rotating circle can spin to connect any 2 points on the globe, and trace out the shortest path between them, called a geodesic. A geodesic will always be a section of this largest possible spinning circle. When you look at the flight paths taken by planes, they might appear to go in arcs that would make the trip longer. But they're actually following geodesic paths that are part of a circle with its center at the middle of the Earth. These geodesics show us that something that is logical might not seem logical until you can see it from the right perspective.